Now, how do we determine if a molecule is polar? Okay, to do so, we need to look at two factors. The first factor is this. We need to see whether or not there is even a polar bond within the molecule. There will be a polar bond within the molecule as long as there's a difference in electronegativity. Okay, which means you must have at least an atom that is electronegative. In your A-level syllabus, the electronegative atoms are FON, CL, Bri in general. Okay, where this one is the most electronegative. Okay, so the first factor, you need to have at least an electronegative element, an electronegative atom in order to have a polar bond. Next, you need to look at the shape of the molecule. Do the dipole moments cancel out? So for example, O is electronegative, so there'll be a pulling towards this direction and a pulling towards this direction. They do not cancel out because the shape of water is bent. So overall, there's a net dipole moment upwards. Same thing for CH3F. F is electronegative, so there's a net dipole moment upwards. For CO2, oxygen is electronegative, so it will pull and it will pull, but because the shape is linear, the dipole moments will cancel out. So therefore, it is considered to be a non-polar molecule. So to visualize this, you just need to imagine that you are the central atom, and then there's someone pulling you in this direction and another person in this direction. You ask yourself, do you move? If you move, then you are polar. If you remain at the same spot, then you are considered to be non-polar. But this is just an imaginary exercise. The atom itself is not moving. Okay, it's just a way to understand it, to visualize the polarity. So for example, Cl is electronegative, so it will pull in this direction. So therefore, yes, it is polar. CO2 is non-polar as mentioned. CCl4 is tetrahedral. It is fully symmetrical. So all the dipole moments will cancel out. So this will be non-polar. CaCl3, it will pull in this direction and it does not cancel out. So therefore, it will be polar. Br3 is trigonal planar. It will pull, but because it's fully symmetrical, all the pulling motions will cancel out. So therefore, it is non-polar. NH3N is electronegative, so it will pull in this direction. Okay, the dipole moments do not cancel out, so therefore this is polar. So this is how you determine whether a molecule is a polar or non-polar molecule. So that's 1 minute of chemistry. See you the next time.